Good morning, champs. Today we solve our first complete truss using the method of joints. The truss is symmetric and carries an 8 kilonewton downward load at the top joint. Our goal is to determine the axial force in every member and identify whether each member is in tension or compression. We begin with the support reactions. Because both the geometry and the loading are symmetric, the two vertical support reactions must be equal. There are no horizontal external loads, so the horizontal reaction at A is 0. Vertical equilibrium tells us that the two vertical reactions must add up to 8 kilonewtons. Therefore, the reaction at A and the reaction at B are both 4 kilonewtons upward. Before analyzing the joints, we examine the geometry. Each upper sloping member has a horizontal projection of 4c and a vertical projection of 3c. Its length is therefore 5c. This gives a cosine of 4/5 and a sine of 3/5. Each lower member has a horizontal projection of 4c and a vertical projection of 1c. Its length is the square root of 17 times c. Its horizontal direction ratio is 4 divided by the square root of 17, and its vertical direction ratio is 1 divided by the square root of 17. We now choose our first joint. Joint A is the best starting point because the support reaction is already known and only two unknown member forces meet there. These are the forces in members 1 and 4. As always, we initially assume that both unknown members are in tension. This means both force arrows point away from the joint. A positive result will confirm tension. A negative result will mean that the member is actually in compression. At joint A, horizontal equilibrium relates the horizontal components of members 1 and 4. Vertical equilibrium includes the upward support reaction and the vertical components of both member forces. Solving the two equilibrium equations gives the force in member 1 as negative 10 kilonewtons. The negative result means that member 1 is in compression with a magnitude of 10 kilonewtons. The force in member 4 is 2 times the square root of 17 kilonewtons, which is approximately 8.25 kilonewtons. This result is positive, so member 4 is in tension. Because the truss and loading are symmetric, we can immediately determine the corresponding forces on the other side. Member 2 has the same force as member 1, so member 2 carries 10 kilonewtons in compression. Member 5 has the same force as member 4, so member 5 carries approximately 8.25 kilonewtons in tension. Only the central vertical member remains unknown, so we now analyze the top joint. The two upper members are compression members, therefore their actual forces at the top joint point toward the joint. Applying vertical equilibrium shows that the central member must provide the remaining 4 kilonewtons downward at the top joint. Since our assumed member force points away from the joint, the positive result means that member 3 is in tension. The final results are as follows. Members 1 and 2 each carry 10 kilonewtons in compression. Member 3 carries 4 kilonewtons in tension. Members 4 and 5 each carry approximately 8.25 kilonewtons in tension.